Okay, so we're going to look at some more examples of the integration method. So we're going to look at dy dt plus ty is equal to e to the negative t over 2. So as before, pt is going to be equal to t, which makes mu t is equal to e to the integral of pt dt. So that's going to make that equal to e to the integral of t dt. It's going to be equal to t squared over 2. So now we're going to take ut and multiply it by everything. So we're going to get e to the t2 dy dt plus e t squared over 2 ty is equal to e negative t over 2 times e to the squared. Oh, yep, sorry, that was supposed to be squared. Which is going to make this equal to e to the 0, because you're just going to subtract, or well, you're going to add them together, and that's going to equal 0, which is going to equal 1. So now we have e to the t squared divided by 2 dy dt plus e to the t squared divided by 2 ty is equal to 1. And as before, we know this is equal to d over dt times u of t times y, which is going to be e to the t squared divided by 2 times y. And if you want to do this yourself, when you take the derivative of this, it should equal this equation right here. I'm not going to do it. I've done it before. You can check out the other videos when I prove this. But now you're going to multiply by t dt, take the integral. We're going to get this. This is going to be t plus c. And then we're going to get y by itself. So y is equal to t e to the negative t divided by 2, t squared, sorry, plus c e to the negative t squared divided by 2. And that is our first example, and that's our general solution, c being some constant. Alright, so now we're going to do another example, and this one, it's going to be 1 plus t squared times dy dt plus 2t ty is equal to cosine t. So the first thing we want to do is get it into the form that we know, which is dy dt plus pty is equal to g of t. To do that, we're going to divide by 1 plus t squared. So dy dt plus, I'm going to separate the y, 2t 1 plus t squared times y is equal to cosine t divided by 1 plus t squared. So this right here is our pt, and mu of t is equal to e the integral of pt dt. So we're going to plug that in, this whole little bit. And then we're going to use u substitution to do this. U is equal to 1 plus t squared. Du is equal to 2t dt. And we're gonna substitute, which is gonna give us e to the 1 over u du, which is then gonna give us e to the ln of u, which is e the ln of 1 plus t squared, which is equal to 1 plus t squared. So now we're going to multiply everything by u of t, or mu of t, which is equal to 1 plus t squared. So dy dt times 1 plus 1 plus t squared times this, which is going to give it 2t y is equal to cosine t. And then before, like we know, this whole thing is going to be equal to ut, so 1 plus t squared times y cosine t. So then we're going to integrate both sides with respect to dt. And that's going to give us negative sine. Wait, no, that's, yeah, no, it's a negative sine. Yeah. And then we're going to get y plus c. Then we're going to get y by itself and divide everything by 1 plus t squared. So y is equal to negative sine t, 1 plus t squared plus c over 1 plus t squared. And then that is our solution for this problem right here. This little thing, whatever, close enough, but alright, I'm going to do another example. It's going to be a initial value problem. Okay, we're going to do another integration method example, and this one is going to have an initial value. So we're going to do, let's do t times dy dt plus 1, or no, t plus 1 y is equal to, let's say, 2 e to the, no, it's not, 2t to the negative t, and let's make the initial value y1 is equal to a, and then we're going to make t is just greater than 0. It's, yeah, it's whatever. So let's first get it into the form we like. So we're going to divide by t to get dy dt plus t plus 1 over t, y is equal to 2. Actually, that's going to get rid of that t. So e to the negative t. Alright, so then u of t, or p of t, sorry, is equal to t plus 1 over t, which is then, we're going to do u of t is equal to e, the integral of p t du, dt, sorry. So let's do that integral. E to the integral of t plus 1 over, I'm writing this way too small, t dt, which we can actually look as e to the integral of 1 dt plus 1 over t dt, and then that is going to equal e to the t plus ln. Oh wait, that's, what am I? Yeah, e to the t plus ln of t. And since that's a plus, that is the same thing as e to the t times e to the ln of t. And that is going to be t e to the t. So that is our mu t is equal to t e to the t. So we're going to multiply everything by mu t. So it's going to be t e to the t dy dt, lots of t's, t plus 1 over t times t e to the t times y is equal to 2e to the negative t. Let's get a negative there, times t e to the t. So over here, these t's are going to cancel out. This e to the negative t is going to equal 1. So let's t e to the t dy dt plus t plus 1 times e to the t y is equal to 2t. Okay, so, and from before we know, this whole equation is going to be equal to u of t, which is t e to the t times y. It's going to be the derivative of that. It's equal to 2t, so we're going to integrate both sides with respect to t. And that's going to give us t e to the t y is equal to, oh, that's going to just be t squared plus c. And then we're going to get y by itself, and that's going to be y is equal to t squared by t e to the t plus c t e to the t. I'm gonna move that over here. So y is equal to, that one t is going to cancel out, so it's going to be t, actually let's make it t e to the negative t plus c t, so it's c e to the negative t divided by t, and that is going to be our general solution. So now we're going to do y of 1 is equal to a, so y1 is equal to 1 e to the negative 1 plus c e to the negative 1 all over 1, which is going to give us 1 over e plus c over e is equal to a. So then we're going to multiply by e. So it's going to give us 1 plus c is equal to a times e. Let me write that a little bit better. A times e to the first, and then we want to get c by itself, so c is equal to a e minus 1. So then we're going to take this c and plug it back in. It's going to give us y is equal to t e to the negative t all over, oh, no, it's not over anything, plus a e minus 1. I'm actually going to bring this e to the t down there. E to the t times t. And that's going to be our solution for this problem with y of 1 is equal to a. I'll write it. I got to write this better. This y t is equal to t e to the negative t plus a times e minus 1 all over e t. Let's throw this t out there. So that is our solution of how we solve this linear first order differential equation using integration method. And I'll be posting some more problems later on in the week probably. So hope this helped.